So this is stoichiometry. Now we're moving into stoichiometry, and what exactly is this complicated work of stoichiometry? Well, in essence, stoichiometry is just looking at the relationship between the ratios in a reaction. It's actually not as complicated as the name sounds. So if you were to be given a chemical reaction, even just like this bike example, right? In order to make this bike here, this is like the recipe to making this bike. I would need 2 wheels and 1 frame. Of course, we're neglecting all the other parts. And this will give me 1 bike, right? This is my standard recipe to make this bike. This ratio of 2, 1, and 1 is not going to change because this is what the recipe is. If you were to bake a cake, if you're looking at how much flour to put in compared to sugar, that ratio is going to be the same because that is your recipe. So in stoichiometry is looking at the ratio between this number, this integer number, this number, and this number, and what the ratios are between them. So if I were to ask you, using this recipe, how many bikes can I make with 10 wheels? And you can probably doing simple math that, well, if this is the recipe, if 2 wheels give me 1 bike, then if I have 10 wheels, then I can only make 5 bikes, right? Because all of my bikes, right? All of my bikes would be taken up. Here's 1 bike, and here's second one, here's the other one, and then here's my other one, and then here's my 5th bike, right? That's the maximum number of bikes I can have. That's essentially what stoichiometry is. That's your relationship between the molar, or the integer, or the coefficient, I should say, be in front of the number. So how does that relate to a chemical reaction? So if you were to look at this reaction right here, right? I have hydrogen gas, nitrogen gas, and ammonia gas. This is, like the previous example, like a recipe. In order to make this nitrogen gas, I have to have 3 amounts of this hydrogen gas and 1 amount of this nitrogen gas to give me 2 NH3. So if we were to look at this, this is my first molecule, here's my second molecule, and this is my 3rd molecule in this ratio. And if I were to combine this to my N2, that's my nitrogen gas, all of this is going to combine into 2 of these ammonia molecules. So you notice that the ratios are very important in determining how much I have. And that's really what stoichiometry is, right? So what it is that I need 3 of these plus 1 of these to get you 2 of these. That's why balancing reactions are so important, because if you don't balance the number of hydrogen atoms, number of nitrogen atoms, number of nitrogen and hydrogen atoms on this side, then your stoichiometry ratios would be off, right? Because then if you just have 1, 1, and 1, well, that's not really right. You have to make sure that you're balancing your reactions correctly. So stoichiometry is looking at the coefficients, the molar ratios. So when we talk about molar ratios, right? Molar ratios, that's looking at the coefficients in front of these elements or these compounds or molecules. So this will have 3 moles of H2 will combine with 1 mole of nitrogen, N2, will give me 2 moles of ammonia gas. So that's your molar ratio, 3, 1, and 2. So why is this important? Well, the next question here is that, well, if we were to be given, say, 5 moles of H2, and you need to manufacture NH3, ammonia gas, how much of NH3 can you get? And we can even extend it. Well, we know about molar conversions. What if we were to be given, say, 55 grams of H2? How much of ammonia gas can you manufacture and synthesize, right, with grams? That's the importance and why we learn about stoichiometry, because now we are using these molar ratios and we can determine how much of the product that we can get. And also in stoichiometry, it's not just about the reactants and the products, like how much of the reactants you get for your products or how much products you get from your reactants. You can actually use stoichiometry and molar ratio to find out, well, if I have 3 of these, how much of N2 do I need? And that you can use stoichiometry as well. Remember, this is your recipe. These ratios are going to be set. So if you have 6 of these H2s, you're going to have 2 of these N2s. And then you're going to have 2 NH3s. If you have 12 of these H2s, this is 4 times, you're going to have 4 N2s plus 8 NH3. I think I did this one wrong. This one should be 4. Right? So that's your stoichiometry, looking at the molar ratios, which are your coefficients in front of your molecules. And check out the next video for an example question. Thanks for watching.